Okay, let me share the screen with you. So, welcome to Introduction to Streaming. Let me start with a bold statement. I think that web is slow right now. In fact, it's getting slower each year. As you can see from the HTTP archive data, there is a linear growth in bundle size over years. And bundle size is a part of a bigger picture. You can see there's a jump in JavaScript boot up time. There is no direct correlation between bundle size and execution time. We'll focus on one of the reasons why that is and trying to find a solution for that. Let's talk about rendering on the client. It's good for updating UI after the initial load, but it doesn't handle first render well. That's because we have to wait for the HTML and JavaScript to load first, before we can see any content on the page. That leads to poor total blocking time, first contentful paint and largest contentful paint metrics. Ideally, we'd like for a server to perform initial render, so the user sees content sooner, and then updates the UI on the client. Indeed, there is an approach called server-side rendering, which does exactly that. It renders initial content on the server and performs updates on the client after hydration. We'll discuss that in detail later. But you see, there's another problem. Both client-side and server-side rendering suffer from a specific issue, and it's called synchronous rendering. Synchronous rendering means you'll have to wait for the whole rendering process to finish until you can see the result and interact with it. Even though you might have rendered the most of your app, that one slow service will slow down the whole app. So is there something we can do about that? And I say yes. It is called streaming. Streaming means sending data over time. Streaming is not a new technology. It has been with us since 1997. With streaming, you can send your content in small chunks as it renders. It means much lower FTP and LCP times. In addition to that, you can start your request for CSS and JavaScript much sooner. What it also allows us is to render large amounts of data with no visual delay at all. That's a really hard task for client-side rendering. Let's look at these examples. You can see that the one on the right appears to be much faster, but they finish loading almost at the same time. That's what improved FCP and LCP means to users. In most cases, streaming is actually slower than synchronous rendering in terms of total render time. But what is important is perceived performance. The interface feels much more responsive, though it might take more time to actually complete the task. So how does it work? HTML is the key technology here. Because HTML is error tolerant, browsers can render it while still loading. That's called progressive rendering. You don't need to send your closing tags before you can show anything. A browser will close them for you. Simply put, you send in HTML chunks over time, and browser displays them after they are parsed. You send these chunks over HTTP, which supports chunk transfer encoding since HTTP 1.1. The next question is, how do we apply this to a component-based approach? Well, we use SSR for that. SSR takes your component and request parameters as an input and returns an HTML string. Vue and React support streaming SSR out of the box. There are more frameworks which can do streaming. And to do proper streaming SSR, your components should have a way to tell they are awaiting an async operation. This is usually handled by the framework. Okay, we can stream the whole document, but what if we have client routing or just want to stream a heavy part of the page? It is possible, and I call this partial streaming. Partial streaming was described by Jake Archibald in 2016. It streamed inside an iframe and moved an element out of that iframe to the original document. Unfortunately, this method does not work reliably now, but there is another way of doing that. You can stream into a new document instance and then place some part of it into an original document. This method has been proven to be very fast and also reliable. So it's time to finally see it in action. Okay, we'll try to compare client-side rendering with streaming in this demo. Take a notice of the JavaScript heap size when I start rendering both of these variants. I'll try to render 200 instances of similar components, and it is not a lightweight component, it's a heavy one. So let's try to render it. As you see, JS heap size starts growing rapidly. We already reached 1 gigabyte mark, and it's still loading. Now it's loaded, it's fully functional, we can interact with it, and it's working. This is how we are doing stuff right now. So this is a classic approach of client-side rendering. Let's try to refresh the page and wait for the heap size to come down to its initial point. Okay, and let's try streaming. You might have blinked there and missed the loading label. I try it once again. So as you can see, it starts streaming as soon as I hit this button. There is no visual delay at all. And also take a look at the heap size. It's also kept to a minimum. It starts growing where I scroll the page because these components start to initialize. And as you can see, they are also interactive the same way we are interactive with the classic rendering. So that is the benefit of streaming. Now let's get back to the presentation. It all looks good on the surface, but there are actually complex problems that come with SSR. First, you need to hydrate your markup. In a nutshell, it's a process of making your page interactive. Because of that, you have to ship more code, both JavaScript for hydration logic and HTML to recover your application state. It is also not a plug-and-play solution in most cases. That's because all of your components must be universal. These components should work in both browser and node environment. There is also a separate build step for the SSR app. And finally, of course, you need Node.js to run the JavaScript. Let's have a deeper look why hydration is a complex problem. First of all, you have to send all your app state with HTML and then use state to recover from it. Secondly, you need to perform that same thing you just did on the server. You create a full component tree of your application. Then you can actually perform DOM operations, specifically add event listeners. And finally, you can trigger your side effects. The problem with hydration is that it's synchronous. You have to wait for the whole app tree to hydrate to complete hydration process. Before that, you cannot interact with an app. That's how it's done in React and Vue out of the box. When we add partial streaming to the mix, we have to solve even more problems. We need to figure out how to restore scroll if the user refreshes the page. We also need to handle back and forward cache, so there is just not a blank page in front of us. And lastly, we have to support anchor links that do not appear there on initial page load. The good news are that these problems are solvable. To solve them, we have a range of options. First, I should say that this is an area of active research right now. There are solutions that try to completely avoid hydration, but we'll focus on what we have at the current moment. I'll just list some of the obvious solutions we have, since this is only an introduction. We can solve some of the hydration issues by using an approach called lazy hydration. It means pausing hydration until a certain event or action. It requires your framework to support resuming hydration later on. Another option could be to perform a manual hydration. For example, create a separate instance of an app and also hydrate on a specific condition. It allows for hydration to happen before the app is fully rendered. We also have async imports to solve issues with components that use DOM-dependent libraries and DOM API in general. And to mitigate the high cost of moving the whole page to SSR, we have partial streaming. Okay, so let's see partial streaming in action. I've made a simple proof of concept to show you that it is in fact doable even for complex apps like GitLab. Sorry, not this one. Yeah, this one. So the page is already loaded now, and as you can see, it's your usual merge request with lots of files. They're all rendered at the moment. Don't mind the spinners on the right. It's still a proof of the concept. And yes, these are not like fully functional instances. So it is just to show that streaming is possible to be done in this page exactly. So let's try and refresh the page. As you can see, we can already see the contents of the merge request before the whole page is rendered. So we don't have to wait for the whole 54 files to be rendered before we can see the first file. We can already start reading the merge requests and, I don't know, reviewing some of the stuff. Also, let's try refresh it once again. Take a closer look at the sidebar. As you can see, some of these links are grayed out. That's because this content is not loaded yet. So when it's loaded, these are actually updated. It works. This is actually an implementation of manual hydration I've discussed before. It uses web components, it places them after the file, and when these web components mount, they actually update the sidebar. So that's one way of doing manual hydration. Also, let's go to the more complex page. This page has 172 files. If you try to load this using client-side rendering, you're probably going to crash your browser. And let's try to do that with streaming. Of course, this is not optimized at all. This is very basic stuff, so it might take a while. So you can see, yes, it struggles a bit, but it still loads. We don't have to wait this whole time to render all these files before we can actually see some first files. So that is basically a demo for a simple implementation in MRs. Okay, let's get back to the presentation. But there's still a big problem there. You have to set up a node server to do SSR. I was using a node server in a previous example. So could that be an option to avoid that? And the answer is yes. Let's get back to the first demo I've shown you. And also let's take a look at the network panel. Let's start streaming and see how many requests do we have. And there are actually none. There are no requests when we were rendering this. So even the first example was not using node server. So how is this even possible? It was all possible by using web workers to stream our components. We didn't actually run any server to render these components. With partial streaming done via web workers, we get even more benefits. Obviously, we no longer need our node server with us. Since we are not sending data over wire, we don't have any network latency to receive HTML. We also don't have to send our state in that HTML because we can send the state as parameters, reuse our requests, or even use shared array buffer to read from the same part of memory. Most importantly, that approach does not block main thread, contrary to classic client rendering. And it also significantly reduces memory footprint because it frees up memory as soon as the worker completes the render. Lastly, it is available in Vue 3.2. This approach is very fresh, and of course, it has its own challenges. These are yet to be figured out because no one has done it on a large scale to this moment. To sum up, client-only rendering is perceived as slow by users. We can use SSR to improve that, but it also suffers from synchronous rendering. Streaming solved the synchronous rendering issue. partial streaming lets us integrate streaming on a per element basis. And lastly, partial streaming with web workers allows us to stream without a node server. And that's all for today. Thank you. Any questions?
I have the first one, the most obvious. First of all, thank you for an amazing presentation. It was really good. Do you have the source code for your Vue project somewhere to share?
The one with workers is already publicly available. I will link it in the notes for this presentation. The one with the GitLab will be posted after presentation, I guess in a couple of days.
Thank you.
The GitLab demo you did you say that that was using a node server?
Yes.
Okay.
The demo with GitLab, we couldn't use web workers there because it requires Vue 3.2. So there's just no way to launch that with current GitLab code base.
Just curious, like, what's the sort of weight of the code that you had to write to get that demo working? Like 1,000 lines, 100 lines? What sort of order of magnitude are we talking?
I guess more than 1,000, more than 10,000 probably, because I actually had to replace the whole GitLab UI library because it is not compatible with universal components. It uses some DOM operations, so I replaced it. The replacements actually took like 1 or 2 lines, just using conditions. But yeah, when you see the merge request, you will see that there are more than 10,000 lines changed. Don't be scared by it. It actually is less than that, but it's still a lot of work, like migrating all of the libraries GitLab is using right now. So GitLab UI, Bootstrap UI, anything else that uses DOM. So it has to be aware that it is running inside the node server.
Now, I guess we're all thinking about what is more realistic, to make this change or migrate to Vue 3. I mean, both are super complex.
I think you can see this as one of the rewards for going through that journey, I guess. It opens up this possibility among many other things.
Can you go through a little bit about how the web worker approach works? Like a high-level overview, because I don't really get it.
Yeah, it works the same way it works with server. You have a separate build. So there is a separate build of your app specifically for web worker stuff. And it has to be stripped down of any assets. So you have to remove your CSS, images, anything like that. So if you are importing CSS in your JavaScript, you should remove that. Or at least you have to tell your bundler to remove these requests. Otherwise, web worker will try to load this and fail. That is one of the limitations of web workers. Other than that, it works exactly the same as an SSR app. Vue has decoupled its streaming and server-side rendering from Node. So you just can replace Node with anything else, and it will work. So basically, that's it.
But like, what's the communication between the web worker and the main thread? Like, is it posting HTML strings basically, and then they're just dumped into the DOM, or is it something more nuanced than that?
There are 2 ways you can do this. You can use your regular post message to send your HTML. And another way is sending back. It's called web stream. I don't know the exact name. Something like web stream. So it is actually a stream instance sent back to the main thread, and it can be used as a regular like fetch stream. So you render using that. I've tried both approaches, and it seems that the one with post message is the fastest one because there is a lot less work has to be done around the stream. You just use these bytes and insert them into HTML, and that's it.
Have you ever seen any bottlenecks in terms of performance with the web worker? Because I remember we had some places that we used workers, I think in the IDE, in the web IDE, and then it turned out sometimes to be a bit slow. Have you ever seen anything like that with this approach, where the web worker becomes a bottleneck?
Well, first of all, web workers have to bootstrap, so it's not like immediately available to you. It has to launch. Also, one of the problems with web workers is that you have to send all your props to that web worker. I have partially described it, that we can solve this by using shared array buffer. We can reuse requests via service workers, but I haven't really tried it yet. So sending data to a web worker is a bottleneck. So if you have like 2 megabytes JavaScript object, it might take a while to be sent and to start rendering. So you have to work around this.
So basically keep the data to the bare minimum, keep it very dumb and small.
There are two approaches.
Okay.
So one approach is to like get the data on your main thread first, then send it to your worker. That's one way of doing it. Second way is you start your requests both on the main thread and in worker. So you have 2 concurrent requests. And you have to somehow guarantee that both of these requests return the same data to each thread. So basically these 2 approaches.
Sorry, can you repeat the second? I was typing.
Yeah.
Second approach?
The second one, you have
Sorry.
2 concurrent requests. One is running in your main thread and another one is running in your worker thread. So worker thread is actually rendering as it gets some data. So you can actually launch like 10, 20 requests in this worker. But you also have to launch all these requests in your main thread to then compare the markup that you were given to the application tree you have on the main thread. So you are not rendering, but you are building your application tree to then make it interactive. So when you like click a button, the state updates and the whole application is working.
Got it.
We actually before that I tried the approach with like concurrent requests. It seems to be the fastest one because you don't have to wait for the data to load like on a main thread. You just can start rendering. But it is challenging in terms of making that both of these requests are actually returning same state. You can have mismatched state, and it gets challenging when you start hydrating your HTML.
Any more questions? I have some thoughts and questions as well, but I don't want to. Anyway, so it seems like this is comes with a bit of an overhead in terms of approach. And in code review, we have the experience of already having that overhead with the current approach of having batch requests and all that stuff. So from going where we are right now, is it more complicated or less complicated than if you're starting from scratch? Like if you started just a normal list, one request, one list, is that easier or harder than what we have right now in code review, where we're already breaking it up by multiple requests? Does that make sense? I just want to understand what's the easiest path to get here. Is it where we already have the app already broken up by multiple requests and all that stuff, or is that a hurdle?
With streaming, the more stuff you break down, the better it works. So if you can break down like even by a single line, it is already better, because you can start rendering without waiting for the whole like file to be fetched. So the more stuff you break down, the faster you get it on your display. If we can do this, that's great. But it works even with the current implementation, where you fetch file by file or in batches. It also works, but not as quick as if you could like fetch it line by line.
So what you're saying is it's easier if you're starting without that logic of breaking things up and just leave that to the streaming.
You still have to break stuff up. So if you want to stream something, you have to send it in chunks anyway. If you like send the whole diff file in a single pass, you'll have to wait for this file to load first, and only then you can start streaming. That is the problem.
Is anyone thinking about their own use cases for this approach that you want to share? I can think about probably, so Jacques, you're on the call, repository file list, where we could probably use this for really large folders with a lot of files. Is anyone else thinking about any of their own use cases that might have some specific bottlenecks or questions?
Large boards for plan. First that comes to mind is like huge performance bottleneck there due to loading that many cards, especially in super wide or super deep board. So this could be a case, definitely.
I also have one case in mind because I worked on this page recently, like file views that have 10,000 lines of code. They would definitely benefit from this. So that's one of the pages.
That presents itself an even deeper, interesting thing, where we're just now working on highlighting it on the front end, which gives a lot of possibilities for leveraging streaming and highlighting to make things lighter as we go on the file view instead of just rendering the whole thing on the back end. I don't know if you can highlight partially, but we'll work on that. Any more cases?
I mean, not that many groups on the call. Like I see it's 3 people from Plan at least. So
like even
share the same words.
Even on your regular overview MR page, where you have like hundreds of comments, instead of hiding most of them, you can just stream them. So that is also a case. So basically, like if you are dealing with user-generated content that cannot be paginated or like using virtual scrolling, like if it's text, So that is a good solution for these cases, I think.
I mean, even if it can be paginated or virtual scroll, sometimes we just use this pagination and infinite scroll just as a last resort because we don't have any other tools. So we just go and use this infinite scroll and pagination. If sometimes we just don't need it, it's just for performance reasons. And maybe it could be replaced by streaming specifically.
Well, if in the case of like a huge MR, like the one you had with 179 files, like, okay, it starts rendering efficiently and early and it's responsive, but as you scroll down, as more and more of the DOM gets hydrated, the page will eventually just become so heavy the browser falls over anyway, right? Or is there something extra going on there?
No, if you start figuring out how to deal with this. This is actually exactly one of the problems I described with SSR, that you have hydration cost, and basically you do the same thing you just did on the server. So to avoid that, we have lazy hydration, and basically what it does, it just pauses your hydration. So you can build your root up tree like this is a list of something. And when you actually get that element in your viewport, you start hydrating. So you just can resume from the state you're given from the server when you actually approach that element. So in terms of memory consumption, it is very efficient if you apply lazy hydration to this. I have a case. We rendered about 1,500 comments using this approach, and it used like very minimal amounts of memory because we use lazy hydration, and it increased as soon as you started scrolling the page. The comments were hydrating, and it was very efficient in terms of memory.
But I mean, as you interact with more and more of the page, more of it gets hydrated, unless there's like a dehydration that it does as well as things scroll off screen or something like that.
A garbage collector for hydration.
Yeah.
Yeah, like I thought about that as well. Yes, I think that it is possible to start dehydrating components. So you just basically remove them from the tree and like remove this instance and still present it like a lazy hydratable component. So it looks like it was sent from the server and you didn't hydrate it. So it is also possible.
Yeah, Mark, my line below is, if anything at all, we already have that problem today. One of the things we've noticed with the merge request is, first, we track the metrics for the rendering, but that's only part of the story of the page. As users interact with it, pages do tend to become slower and slower. If anything, this approach just makes that merge further ahead, and you can interact much more until it starts being usable. So if anything, there's that. So I have a question, if nobody else has anything else to add there. Okay. So earlier when we were talking about workers in response to Mark, did I get it right that this comes with a bit of a cost in terms of dryness? Do you have to repeat yourself a little bit, or can you use the same code for the same component? Or do you only need one implementation of the component for the web worker? Can you talk a little bit about that? Is it one implementation of the code, or do you have to have multiple to support this? I might have missed that.
Well, this is the whole benefit of component-based approach. When you write a component once and it works everywhere. If you make this component universal, you can run it in Node, in web workers, in your browser, as soon as you get a proper check of the environment. If you know your environment, you can make it work in any environment. So you don't have to write any additional code. But I should make it clear that some of the stuff you're used to do with your components in browser is not possible in web workers. You just can't do this. Like the same story I told you about CSS imports. You cannot use CSS block in SFC to apply styles. It just won't work in web worker. And you have to be aware of these constraints. So when you're writing universal components, you have to know that this will run in a web worker and be prepared for it. How long like it will take to migrate a component that is completely unaware of server of web worker, I can tell you. This is the stuff like you can spend months of it and still not figure it out. So it depends, and it should have a deeper investigation, like how difficult it is to migrate GitLab code base to this.
Absolutely. So I think it poses a question about the reusing GitLab UI components, maybe start with something that doesn't reuse them a lot. Yeah, and I like that the way you worded that is this presentation is separate, is necessarily separate from how we're going to implement it and what are the costs and what are the implications of all this. But my mind is blown just seeing the difference of those two demos, and live demos that don't break. You have to share the secret with us. Anyway, thanks for that.
Yeah, demos will be available after the talk, so you can just run it in your browser and see for yourself. If you have a slower device, so the difference will be much more significant. Like I'm running top hardware, so the difference is like it's not striking. But if you try to actually run this on your mobile phone, you'll see like how significant the difference is.
One more quick silly question about this universal check. Is it somehow similar to how we perform these checks on Next or any kind of SSR, like for universal things, like checking if what environment you're running on, or if this is something very different from SSR?
Is it different in the workers environment?
Yep.
As far as I know, no. So probably you have to be more specific in your checks. So sometimes people check for different stuff to figure out if we can use like, I don't know, fetch or something else. You have to be more specific at times, but in general, it looks like completely the same. Also, I should know, like in the demo I shown you the last time, this one comparison, I've made 0 changes to a library I used. So I just put it in my demo and it worked. So I did 0 preparation of this component library and it just worked. So if GitLab UI also does the checks for the Windows stuff, for the document stuff, it can be done for the GitLab UI as well.
Awesome, thank you.
Yeah, I didn't like cover the virtual scrolling approach here, but the entire reason I'm talking to you about streaming is that virtual scrolling doesn't work for text. There is just that. It's just not suitable for text. If you try to search, if you try to select text, if you try to scroll to a specific text, it fails, and it fails hard. It is very painful to work with text. It works very good for media. So if you have like image gallery, it works best there. But when you start applying it to text content, it breaks. So that's the entire reason. Like I was interested in streaming, because it actually allows you to use the stuff you are used to, like searching text, selecting text. It works. It still works. It has some issues with anchor links, as I described. So because they do not appear on the page when you first load it, there are no anchor tags, and the browser won't scroll you to the element. but it can be solved, and solving this stuff like is a whole topic of itself, and we'll probably like cover it sometime later.
Stas, I'm so glad you mentioned this. And it's not an accident that you're in code review, and we've just implemented virtual scrolling a couple of months ago. And now we're talking about streaming. So when we implemented virtual scrolling, it wasn't our first most ideal solution, or nobody was in love with that implementation. We know the pitfalls, like you just mentioned it. It was definitely an interim solution that we begrudgingly followed because it felt like it would drive us to a more acceptable usage of the page, but it's not our final destination. It's an interim solution. Streaming does seem a little bit more manageable in the long term, mostly because of the memory usage. It's so low, or just much lower. Whereas virtual scrolling is a mitigation for the memory usage. Here, I can feel like there's a lot more real user experience gains without the pitfalls. We still have to have the complexity of the code, and that's always going to be there. But ideally, we can have it integrate well with the code base. But yeah, so glad you mentioned this. We do have virtual scrolling, and you probably might want to consider virtual scrolling because you don't have to wait for Vue 3 for that. But see that as an interim step towards a much better performance on your page. But thanks for mentioning it. Anyone has more questions?
No, this is a moment of awkward silence.
I'm guessing once we start breaking apart the demo, we might have a couple more. So that's going to be interesting to do. So in the long run, I can see a requirement for Vue 3 to be in place, or at least for the app where this is used to support Vue 3. Any other hurdles that we need to jump through before we even consider this as a possibility besides that? I mean, support from the browsers, that seems to be good.
Well, first of all, we don't know yet how hard it would be for GitLab to work inside the worker. It's like impossible to test right now because everything is broken. So when we get to the step and migrate to Vue 3, we can start investigating this and figuring out, does it make sense? It might not make sense at all, so I don't know it yet. In terms of migration, I made this proof of concept in a couple of days, so it wasn't like a super hard task. So if you just start fixing errors one by one, so it's actually not that hard to do. I'm mostly worried about libraries that GitLab is using. So some libraries, like you've mentioned, code highlighting. We also have DOM Purify. DOM Purify doesn't work in Node. So we have to find a replacement for those. And this is going to be a challenge, because if you rely on this library very heavily in your code and you cannot replace it, that means a blocker for the streaming.
That actually brings up something I meant to mention earlier. If we are passing from a web worker strings back to the main thread, and essentially we'll be doing inner HTML equals, then potentially that's we're not.
We are not doing that. There is a big difference here. So I also didn't cover that, but it was like a high-level overview. Actually, HTML has streams, so there is an API. If you use it, you'll get an error in console that you're using some very legacy API. and it's called document.write. So what it does, it actually puts your content into a document stream. It is not like an inner HTML. It doesn't update the whole element. It just puts it after the current content. And it's very performant. It's very fast. It's much faster than in HTML. And when we create a new document, we can use exactly that. We don't have like to mess with our current document. We can use a separate document to stream into this document and then pull that element out and get into the original document. And it looks like it's a document inside the document, what it actually, yes, it really is. So it is very fast. It is not blocking main threads like in nothing like compared to client-side rendering when you just stop doing any stuff before you finish rendering.
How is it applied? How is it applied back to the page? Is it goes directly to the element you want to replace? So you said that uses document right, that's on the separate document as it's getting new things, but then you have to pull it back into the original document. And
yeah,
what exactly is the mechanism?
The mechanism is very simple. You just take that document, that element reference, and just assign it to another element in your original document, and that's it. Basically, like if you do stuff with iframes, you can do the same thing, at least in Chrome. It doesn't work in Firefox, but you can do the same stuff in iframe. You get a reference to an iframe element and assign it to an element in your original document, and it appears there.
This only happens once, right? This is not going to be reactive between the worker and the original document. This happens once, and then it's hydrated and doesn't get rehydrated again, right?
Yeah, you just get that element into your original document. You can do anything you would like with it.
Right.
So
Okay.
yes, you have one hydration pass and you're done.
Okay, thank you.
Also, one of the coolest things about this approach is that you actually don't have to wait for the streaming to finish, as I showed in a manual hydration example. So while you put that element into an original document, you can already start hydrating. Not, of course, not automatically, but manually, as I've shown with web components. They start mounting as soon as they're inserted into document, and you can use this hook to hydrate them. Also, as a side note, it's funny because I didn't find like any kind of streaming implementation that's decoupled from Node in any framework. So I checked React, I checked Angular, checked Svelte, and none of them had like implementations that didn't use Node internals. And it was it was done a year ago in Vue, and for some apparent reason, no one has actually done it in their framework. I don't know why that is, but what Vue has actually offers a very unique features that no framework has.
Is this something you can put in a library, or is it this more of an approach? As I'm thinking, because I feel like it's a conjunction of multiple techniques. Could you package it all up in a very easy plug and play turnkey thing, or is always going to involve a couple of things?
Well, what you are actually asking is writing a separate, completely new framework. because to pack this stuff together, you have to design your framework from the ground up with the consideration that it is focused entirely on streaming and on web workers. So yes, it requires a new framework. You cannot like add it into an existing framework and hope that it works out of the box. I don't think that's possible. You can extract some of the stuff like into components, into some logic, but when you tie this all together, yeah, it breaks up. There are frameworks that are actually working on this right now that are thinking from another perspective. So Vue and React, they were designed as a client-side libraries. And their design dictates like how you write code in for a client. And there are actually frameworks like it's called Qwik that are thinking about server-side first approach. So how do we design a framework that works on a server first and then starts on a client? So if you change your mindset and start thinking about server first, you create another set of APIs, another design constraints that allow you to write code in such a manner that it can be streamed easily without all the manual work, or hydrated without issues that we have right now. So yes, it requires a different kind of mindset for this approach to work out of the box. What I've shown you before, both of these demos, they used a lot of manual work. So nothing here was like install a plugin and it works. No, I had to work around the issues we have. I have to use some external stuff. And the framework that can do this out of the box, I think this can actually beat Vue and React when it comes out, but we don't have it. Don't have it at the moment. But I have a feeling that that's the future. Like frameworks are moving towards server-side rendering. This is like a clear direction in what people are doing.
Thank you. I had one quick question. So I understand we're much more interested in the front end part of it, but since we already have work done on WebSockets on the back end and load and stability and all that stuff, what are the most immediate implications for the back end on this kind of approach? We need an endpoint to give us the data that we're going to need for the whole page in one endpoint. But does that generate any load on the back end, any different approach, anything that we can leverage through GraphQL already, or WebSockets, or subscriptions?
Well, it depends. If you're using Node Server, of course, the load on backend will be significantly increased. First of all, because you have to send a lot of HTML. So the stuff you were rendering on a client, it goes on the server and it has to be transferred back to the client. And it can be overwhelming. So if you try to send like 200 files in an HTML, it can significantly impact your infrastructure. So you have to be aware of it. And that is, I guess, the main constraint here. The second constraint here is caching, because if you actually try to render it each time from the fresh start, it also creates a significant load on your servers, and you might not handle that. So you have to cache it. And caching is also its own separate kind of problem. You have to deal with all sorts of stuff. Yeah, that is the downsides of running like a node server. If we are talking about workers, I don't have like any particular data because, as I've said, no one has done it on a large scale. So we don't know like how big of an impact it would be. My first consideration here is that workers have to have a separate bundle. So you have to somehow tell them to use these components to send them JavaScript. And my guess is that bundle size could be doubled. in that case. I might be wrong about this, but it looks like
Sure. I'm mostly worried about the endpoint itself. So what did you use for your GitLab demo? Did you just reuse the ones that already existed on the back end?
Yeah, I just reused the demo that I just reused the API that's used by merge requests, like that sends diffs in batches. So it sends like 3-4 files in batch, and I just configured it to use one file only, and made multiple requests. So when I encountered a new like item in the list, it created a separate request and started rendering. What you saw in the demo is actually not optimized because it was using Vue 2. So Vue 2 has to like make request, finish rendering, then start requesting the next file. With Vue 3, you can do this concurrently. So you first do all of the requests, and when the request finishes, it can start loading this separate component instance. So in Vue 3, it's actually much faster than this.
Okay, it wasn't clear to me that you could still have multiple requests from the server coming into this streaming, because so streaming is streaming the rendering, not necessarily streaming the data source. Got it. Sorry.
Streaming
Same words,
data,
different things.
Streaming data is actually, I think, is also a complex problem that will be hit in the future, because if you are streaming HTML, of course you should be streaming your data, because if you can get just a little bit piece of data and render it, why not do it? So
no, 100%, and that's why I mentioned the WebSockets before, and breaking it up into multiple requests is a legacy approach that we used when we didn't have these fancy things. Well, yeah. So, but this is good to know that we can leverage the existing ones as we transition, and then they can evolve in a separate thread.
Yeah, definitely.
Cool. Are we at time?
Yeah, that's it.
Almost, yeah.
Oh, yeah, okay. Stas, wrap it up.
Yeah, thank you everybody for coming, for asking your questions. I hope we've all learned something today, and I hope like it gets some traction. If you're interested, please come into the document. I'll be linking all the demos there. I'll be linking merge requests with the proof of concept for GitLab. So come there, join in the discussion. If you have any questions, leave them also in the notes. I'll try to answer them.
May I suggest moving
Yeah.
this to some kind of an issue? It would be just easier for everyone to track than Google Doc, and we could share the recording there, slides and everything else, because I would really like to hear what editor team thinks about it. I think they have places besides Web ID they would be super interested into, like big blobs, for example, you mentioned. So it would be nice to have a discussion in something more usable than Google Doc. Sorry for the suggestion, but if you could.
Yeah, sure. We'll create an issue in GitLab, and I'll also link it in the notes. Yeah, thank you, everyone.
Thank you again.
Yeah.
It was
Goodbye.
a great presentation. Thank you. Bye.
Great talk, Stas.